Synthetic division is going to be a shortcut that can be used instead of long division, but you can only do this whenever you have a variable x minus k, where k is going to be a constant. Your k could be a positive number, and we're going to see different examples. For example, 1a, we're just going to determine whether we can use synthetic division. We know from the note that we had at the beginning, we have x minus k or x plus k. So we need to have something like that. In this case, you can see that you have an exponent of 2. In the note that we had, we didn't have any exponent, so we know that we cannot use synthetic division. The reason is because we have this exponent of 2. So if you have a problem like this, you will need to do long division. In this problem, once again, we're just going to determine whether you can use it. We have x plus a number. So in this case, there's no coefficient in the front and there's no exponent. That means that we are able to use synthetic division. And this problem is different because you have a coefficient in the front, you have no exponent. For synthetic division, we need something in the form x minus k, and the reason is that we need to be able to solve for x easily. But for this problem, even though that we have a coefficient in the front, we can actually solve for x. We can actually start by subtracting a from both sides. For x is equal to -8, you divide by 4, you divide by 4, and you get x is equal to -2. Now, because there's no exponent, this is going to be effective to use synthetic division, and you're going to see why. Now that we know exactly when we can use synthetic division, we're going to actually see how to do it. The first thing that we're going to do is make our division very slightly different. We're only going to get the numbers in front of each variable. And we have 3 from the x cubed, then we have 8 from the x squared, then we have 5, and we have -7. The number that we're going to have outside is going to be determined by what we're dividing. So in this case, we have x plus 2. So x plus 2, we're going to make that equal to 0. So subtract 2 from each side, we get x is equal to -2. Because x is -2, we're going to put that outside. So we're changing the sign of whatever we're dividing by. The first step doing the synthetic division is we're always going to bring the first number down. So in this case, we have a 3. And we're going to multiply -2 times 3. That will give me -6. 8 minus 6 gives me 2. And now I'm going to multiply -2 times 2. That will give me -4. 5 minus 4 gives me 1. Then we're going to do -2 times 1, and that gives me -2. And -7 minus 2 gives me -9. We are always going to have the last one as your remainder. This is your remainder. This is going to be the first term without an x. This is going to be the first term with an x, and the next term with an x squared. It's always going to be one less than what you start with. So we started with x cubed, so our answer is going to be x squared. So we have 3x squared plus 2x plus 1, and our remainder we're going to put minus 9, and we're going to make it over x plus 2. Example 4 is slightly different. The reason is that we have x to the fourth, and then we have x squared. So we're missing right here an x to the third. We don't have anything there. So for this problem, we're actually going to use a placeholder. So the coefficient of the first one is going to be 1, because we have 1 x to the fourth. Now we don't have an x to the third, so we're just going to put a 0 there because we're missing that value. Then we continue with negative 10, negative 2, and 4. And again, we're going to change the sign of whatever we're dividing by. So we're going to put negative 3. We bring down the 1 as our first step, and now we multiply negative 3 times 1, and we're going to put that up there, and we get negative 3. 0 minus 3, we get negative 3. Negative 3 times 3, we get positive 9. Negative 10, and positive 9 gives us negative 1. Negative 3 times negative 1 gives us positive 3. Negative 2 and 3 gives us positive 1. And then we have negative 3 times 1, negative 3. Our remainder in this one is going to be 1. And then we're going to rewrite this as x to the third minus 3x to the second minus x. We don't need to put the 1. We can just put minus x plus 1, and the remainder is going to be 1 over x plus 3. For this problem, we know that we have x with a coefficient in the front, and then this is where we're going to see what happens in this case. So we have 5. We're missing the x to the second, so we're going to put a 0. Then we have a 6 and an 8. The number that we're going to be dividing by in this case is not going to be just negative 8. This is where we have to solve for x. This works only when you don't have an exponent. So if you have an exponent, you have to go with long division. So now we're going to be dividing by negative 2. We're going to follow the same process. We're going to bring down the 5. And we multiply negative 2 times 5 gives us negative 10. 0 minus 10, negative 10. Negative 2 times negative 10 gives us positive 20. So we have 26. And negative 2 and 26 is going to give us 52. So our answer is 60. In this case, our remainder is larger, but we're going to get 5x to the second. Again, 1 lower than what we started with, minus 10x plus 26, and with a remainder of 60. If you see a problem where you have no remainder, in those cases you don't have to write the remainder.